Hello, in this video we're going to derive the mean and the variance of a beta prime distribution. Now beta prime and a beta distribution are very closely related. I would call them cousins from one another. So here's the distribution or the PDF for a beta prime distribution where alpha, beta, and x are all real numbers greater than 0. So let's first derive that it is a PDF. So we want to integrate this over all possible values of x, and it should integrate to 1. What we're going to do is we're going to do a change of variable. We're going to let y equal x plus, or y over 1 plus x, solve for x, but we can take the derivative of y, or both sides, and we get 1 over 1 plus x squared. We can solve for x, and we'll need that for this, and then in here we can solve for 1 plus x, which we will need this. Now notice that to complete this we're going to need to pull out 2 of this 1 plus x, but then subtract it, so when we make this substitution. So, and that's what we do here. So this comes down, we substitute x in here, we substitute 1 plus x in here, and that's where the minus 2 went. 2 of those went for this change right here. And when we plug in our limits of integration to here, it goes from 0 to 1. When you solve for this, so this stays the same, you get y raised to the alpha minus 1. And here, this kind of invert and multiply, and then the alphas cancel, and the one of those cancels here, so we're left with beta minus 1. And this right here is sort of what we commonly know as the beta distribution, and it does integrate to 1. And I'm going to skip that step, just assuming that you're familiar with the beta distribution integrating to 1. If you're not familiar with how to show that, I have a video on mean and variance of a beta distribution, which I show in more detail. So that does integrate to 1, and so the beta prime distribution is a mean. Now I put an asterisk here for this transformation because we're going to use it 2 more times, this exact transformation. So when we find the mean of it, we stick a x times the density and integrate over all possible values. Now I'm going to pass this equal sign to this variable change, and then we come back with this. So here, since one of those is canceled, we get alpha, and it's y over 1 minus y, and then this is the minus 2, remember, because we had to grab 2 of those for the dy. So now when you invert and multiply and simplify this, you come up with this. And then I write it like the plus 1 minus 1, because then this is what I like to think of as the beta distribution. And so this is constant, so we pull it out and we're left with just this piece. So if we had the constants in front, then it would integrate to 1. But since we don't, then it's like the reciprocal of those constants. And that's what we get here. So this piece integrates to that. This just comes down. Now the properties of a gamma distribution, I have a video on that if you want more detail. But of course this cancels with that. There's one of these, so alpha times, this is equal to alpha times gamma of alpha. And then you get cancellation, leaving just that, and this piece reduces to 1, or beta minus 1. And so that's the mean of a beta prime distribution. And so let's derive the variance. And again, we're going to pass off to this in just a second. Oh, but one other comment, that see how when we had the mean, we could actually stop at this step, and then this is the mean. Of course, it simplifies to this. But notice that in the x squared, so this is like the first, raised to the 1 power. And then we have plus 1 and minus 1, all right, in this, okay? And I'm going to bring your attention back to that in a second. So here now let's look at the second moment, which is what we'll use to derive the variance. So you stick in an x squared times the density. Now we're going to pass off to that change of variable on the back side of this page, and we get this. And so notice here that it's alpha plus 1, and so that's where this alpha plus 1, and we substitute in. Oh, I don't have a pen with me, but here's a pencil. And so this should be a y. So then this simplifies to this. It should be alpha plus 1, but I have to go plus 2 minus 1. And then this is in the form of the beta distribution. And now this is constant, so it goes out front, and we're integrating just this, which is the beta. So there's no constants in front, so it integrates to the reciprocal of those constants, which is this. Okay, and notice if we were to stop here, that this looks exactly like what we'd had for the mean, except we have plus 2 minus 2. And notice that that's a squared. And actually that's a general formula. So if we have x to some integer n, it would boil down to this, and it would be alpha plus n, gamma of beta minus n. So that's a general formula that you can use. So, but this reduces to this constant here. So this is the expected value of x squared. Now to find the variance, it's this relationship, and so you plug in the information you got and square the mean, this piece, and then you can do some algebra, and that simplifies to this, and so that's the variance of a beta prime distribution. Well, hope you enjoyed this. I did. Please like it if you did, and subscribe so you don't miss the next one. Thanks. Bye.